Okay. So I was saying CH4, C2H6, C3H8, C4H10. What do you think would be the general formula of these compounds? Let's say you want to get the formula of the 10th compound, what would it be?
The third compound would be, let's second, that's third, that's fourth.
C10.
C10
Okay, C10. Uh-huh.
would be C10H22.
Okay. How do you get that?
Because CH2, CH4, I mean, because using CH4, it's like you double the next number of C. Like if C is 1, you go to 2, then you double 2, and then that's H. I don't know.
So we can see it's 1. Uh-huh. You get to
Then
2.
go to 2, like the next number.
That's 2.
The C, if C is N,
Okay, C is
like
N. Good. Uh-huh.
number is N,
So
then
the
you
H,
go to,
H will
would
be
be
what?
1 times 2, like M bracket open, N plus 1, bracket close times 2.
N plus 1 bracket close. Okay. N plus 1 bracket closes times 2. So that gives us what? Cn H2n plus 2, right?
Yes, sir.
And what do you think this is?
Is that the formula? The
That's
general
the
formula?
general formula. Exactly. So that gives us the general formula of the what? Of these compounds. So that tells us that this group of compounds are what? Are members of the same homologous series. Are you together?
Yes, sir.
They are members of the same homologous series because they differ from one another in their molecular formula structured by CH2, and they have a general formula. And if you calculate their masses, you will discover that the difference between two successive members will be what? 14.
Okay.
And why is that 14? Where is that 14 from? From this CH2, right?
Yes, sir.
Great. All right. So let's now move on to functional group. Functional group. Almighty functional group. And what's a functional group? Functional group is what? An atom or group of atoms or bonds that do what? Is common to members of a given homologous series and also determines their what? Their chemical properties. So it is the functional group that will determine the chemical properties of a particular homologous what? Series. In other words, it is what explains the behavior of a given what? A given family of organic compounds. Right? Are we together?
Yes, sir.
It's like the DNA of the organic compounds, the DNA of a particular homologous series. How many siblings do you have?
2.
2. What is common to all of you?
DNA. Similar
DNA.
DNA.
Your DNA, right? Your DNA is what makes you behave the way you do. It's what makes you belong to that family, right? If any of you had a different DNA, you will not be part of that family. True or false?
True.
So if you find a way to be a family of organic compounds, that DNA will be your functional group. Do you understand?
Yes, sir.
And it differs from one homologous series to another. The same way the DNA differs from one family to another. Are we on the same page?
Yes, sir.
Great. So now let's look at the last term, which is alkyl groups. Alkyl group. This is what a group of atoms that has one hydrogen atom less than the corresponding, that has less than the corresponding alkane. Has one hydrogen atom less than the corresponding alkane, right?
Yes, sir.
Remember, the alkane have a general formula CnH2n plus 2, right? These
Yes,
are
sir.
alkanes. So if the alkyl group have one hydrogen atom less than the alkane, what do you think will be the formula for alkyl group?
CnH2n plus 1.
CnH2n plus 1. So they have the formula. They have the formula CnH2n plus 1 and are represented as what? Capital R in organic chemistry. So wherever I see R, capital R in organic chemistry, just know that that is meant to be what? An alkyl group. Are you together?
Yes, sir.
And they determine what? They determine the physical properties of an organic compound. Are we together?
Yes, sir.
Okay. They are named by replacing the ANE in the alkane with what? With YL. Are we together?
Yes, sir.
Named by replacing the ANE in the corresponding alkane with YL. Examples
No.
of alkyl groups are 1, CH3, that's methyl, C2H5, that's ethyl, C3H7, that's propyl, C4H9, that's butyl, C5H11, that's pentyl, etc. You understand?
Yes, sir.
You can see there's a bond before a group. C4H9 hyphen bond C37 bond C3, because that's to show you that there's something missing, right?
Yes, sir.
That group of atoms is not complete. It's actually meant to be CH, either CH4 or CH3 something else, right?
Yes, sir.
But not CH3 alone. So that's why that bond is there. Are we together?
Yes, sir.
Any question?
No, sir.
Okay. All right. Can I clear my screen?
Yes, sir.
All right. Let's look at the table that contains homologous series and their functional groups. Okay. You can see
Yes, sir.
in the syllabus, the following conventions are used. X to represent a halogen atom. Yeah, that's another thing too. X, wherever I see X, represents halogen atoms in organic chemistry generally. All right. And
Yes,
then
sir.
R and R prime represent alkyl groups, or in some circumstances, hydrogen represent hydrogen atom, but generally represents what? Alkyl groups, right?
Yes, sir.
Can be the same or different. Now, what happened here? They are starting from the alkenes, without the alkanes. They did start from the alkanes.
Mhm.
Why is that so?
Isn't that where we start? That's how we move on to the alkyl group.
Alkanes. Why
Uh,
didn't they add alkanes here in this table?
Oh, because they're single bonds.
They are single, but they don't have any special functional group, right?
Yes, sir.
So when you're talking about functional group, it starts from the alkenes. Are we together?
Yes, sir.
Okay. So the name of the functional group for the alkene, the homologous series is alkene. Name of the functional group is carbon-carbon double bond. You can take a screenshot of this. So carbon-carbon double bond for the alkenes. Then this is a structural formula with the functional group, right?
Yes, sir.
You can see when once you see this in the molecule of the compound, just know that this is what? An alkyl, an alkene, right?
Yes, sir.
So this is displayed formula, this example, this propene, this is propene, right?
Yes,
We'll
sir.
still, this skeletal formula, we'll still talk about this later, right? Now this
Yes, sir.
halogenoalkanes. So we call it haloalkanes, right? Or halogenoalkanes, the same thing. So what's the functional group? The functional group is the what? Is the halogen atom. And this is how to represent it. So even that this can also be represented, general formula can represent it as what? Cn H2n plus 1 X, right?
Sure.
So this is an example. That's a 1-chloropropane. Are we together?
Yeah.
Next is the alcohol. Alcohol, under alcohol, the functional group is what? Is the hydroxyl group. And what's that? That's the OH group. That's the hydroxyl, right?
Yes, sir.
So the general formula will be what? Cn H2n plus 1 OH. Because it can be asked which of these represent the general formula of alcohols, right? Which of these represent the general formula of haloalkanes? Are we together?
Yes, sir.
Good. So this is an example. This is the propan-1-ol. Then this is the aldehyde. And the name of the functional group is what? Carbonyl. This is it. That's the functional group, CHO, right?
Yes, sir.
That's Cn H2n plus 1 CHO. It's capital C H O, right?
Yes, sir.
Then we have ketones. Ketones. And you can see that ketones and aldehydes have the same functional group, is it not?
Yes, sir.
So these two are known as what? Carbonyl compounds. They're known as carbonyl compounds. But what's the difference here? Well, the carbonyl, that's the C double bond O. That's the carbonyl compound. That's the carbonyl group, right?
Yes, sir.
While it is between an alkyl group and a hydrogen atom in the aldehydes, right? In the
Yes, sir.
ketones, it's between two alkyl groups. Are we together?
Yes, sir.
So this aldehyde was, as it was Cn H2n plus 1 CHO. Well, this one is what? Cn H2n plus 1 CO Cn H2n plus 1. So this is the general formula for ketones. General formula for ketones. Are we good?
Yes, sir.
Are you enjoying the class?
Yes, sir.
Okay. All right. Then from ketones, we move to carboxylic acids. Carboxylic acids, you can see the aldehydes was C double bond O H, right? But in
Yes, sir.
carboxylic acid, instead of H, you have what? OH, right? So the functional group is what? Carboxyl. Carboxyl. This is the functional group, COOH. That's the functional group. So the general formula will be what? Cn H2n plus 1 COOH for carboxylic acids, right?
Sure.
Good. Now, next is the word ester. Ester homologous series is ester. Functional group name is also what? Ester. In carboxylic acids, the functional group is carboxyl group. Are we together?
Yes, sir.
All right. So in the ester, the functional group is C double bond O. Sorry, COO, right? COO. You can write this as RCOO R prime, right? This will be the R prime. This will be the R prime. Are you together?
Yes, sir.
So then it means to this nitrogen containing, right?
Yes, sir.
NH2. That's the amine group, right? Or you like can call it amino group, right?
Yes,
The
sir.
amine or amino group, anyone. And the general formula is Cn H2n plus 1 NH2. Are we good?
Yes, sir.
Okay. You have the nitrile. The nitrile, the functional group is also what? Nitrile. And nitrile, which one was the nitrile? That's C triple bond N. Remember when we're looking at the features of carbon as a suitable backbone for organic chemistry, we said it has the ability to form double bonds, triple bonds with itself, and also with a few other elements, right?
Yes, sir.
Well, this is one of such. This is it, C double bond O here. You can see it is forming C double bond O with oxygen and all, but also a single bond with oxygen, right?
Yes, sir.
So this will give us Cn, H2n plus 1, C capital N, right? Then we have, there's one that is not here. This one is meant to be in A2, but that's based on this CIE syllabus though. Amide, the amide, the functional group is also amide group. It is R, C, double bond O, NH2, right?
Yes.
That is Cn, H2n plus 1, CO, and H2. Are we together?
Yes, sir.
So you can see that the amide carboxylic acids. So we have amide carboxylic acid, esters, aldehydes, and ketones, right? You can see that all of them here contain the what? The carbonyl group.
Yes, sir.
They all contain the carbonyl group. But these two are a bit different from these other ones. Are you together?
Yes, sir.
Because their functional group is strictly carbonyl, right? While these other ones have additional things added to their carbonyl group. Their functional groups are not strictly carbonyl. They also have additional group of atoms added to their functional group. That's why most people will not classify these ones as carbonyl compounds. Do you understand?
Yes, sir.
All right. We know what a hydrocarbon is. We know that alkanes are just simple hydrocarbons with no functional group, right?
Yes.
We understand the compound in black contain a functional group which dictates their physical and chemical properties, right?
Yes.
Based on those homologous series that are shown. Then, next it will be what? Formulae. Formulae of compounds. Okay, but before we continue, let me just give you a key, the types of formulae. Types of formulae that an organic compound can have. Okay. One is empirical formula. Empirical formula. 2 is molecular formula. 3 is structural formula. 3 structural formula. Are we good?
Yes, sir.
Okay. Let's look at empirical formula. Empirical formula shows the formula that shows the simplest ratio of the atoms of elements present in a compound. Are you together?
Yes, sir.
2 or more compounds can have the same empirical formula. Can have the same empirical formula. It does not give much information. It does not give much information about a compound. Example, the empirical formula of benzene and ethane is CH. So you see CH. If I ask you which one is benzene, which is ethane, how will you know? You will not know, right? Except that the ratio of carbon to hydrogen in the compound is what? 1:1. Are we together?
Yes, sir.
All right. So we'll stop here today. So your assignment, go and read up empirical formula, molecular formula, and structural formula, and types of structural formula, right? So when we start tomorrow, you will tell me about them first before we continue.
Okay.
All right.
Thank you, sir.
Take care of yourself.